Hello viewers, this is Dr. Dheeraj Malhotra, and today we are going to discuss AVL tree, which is a very important data structure. It's basically a balanced binary search tree. So here we go. Okay, so the name AVL is kept in the honor of its founders. That is, you can see on your screen Adelson, Walensky, and Landis. In 1962, they found this data structure AVL. And the unique thing about AVL is that it's a height balanced tree. Okay, and that's why the search time in AVL is quite less. It is expressed in terms of log n. Okay, and height balanced tree means basically the left side and right side cannot be skewed. Okay, so nodes cannot be added in one side, that is either on left side or right side, without keeping track that whether other side is also growing or not. Okay, so this we will discuss with the help of an example soon. However, in order to determine whether a tree is height balanced or not, we have a concept known as balance factor. This is a kind of formula. Okay, so balance factor is basically determined by height of left subtree minus height of right subtree. So for root node, we need to first calculate the height of left part and then height of right part, and we need to subtract them. And if the balance factor is in the range of -1 to +1, if the balance factor calculated through this formula is in this range, then only we can say yes, it's a height balanced tree. Okay, so while inserting any node in a AVL tree, we need to apply this formula. Okay, even while doing deletion, and we need to check whether each and every node is satisfying this condition, that is its balance factor is lying in this range from -1 to +1 or not. In case if it is not satisfying, then we need to apply the rotation, AVL rotation, which is a kind of operation to keep track or to rebalance an unbalanced tree. Okay, so let us take an example. So for instance, if we have a binary search tree like this, okay, so here the value written on each and above node is known as balance factor. So why balance factor of 45 is 0? Because it is not having any left child, not even right child. So balance factor is calculated by the formula height of left tree minus height of right tree means 0 minus 0, and the answer is 0. Similarly for 50, there is height of left subtree is 1 but no height in right side, so that's why 1 minus 0 equals to 1. And similarly for this no child, that's why 0. For this 56, the height of left subtree is 2, longest branch is 2, and on right side it is 1. 2 minus 1 is +1. And for root node, you can see that the height of longest branch is 2, but the height of the longest branch in right subpart is 3. Okay, so please notice that height doesn't mean the total number of nodes. So here the height of left subtree is very clear, it's 2, but many times student consider the total number of nodes in the right subpart like this. So the height of right subpart is 3 because it is the longest branch. We need to always consider longest branch. So 2 minus 3 equal to -1. Okay, so as of now, when we have calculated the balance factor of each and every node, we realized that the balance factor of each and every node is lying in this range, that is from -1 to +1. That's why this tree is balanced and we need not to balance it. Let us consider if we wish to insert a new key with value 42 in this tree. So we know how to insert something in binary search tree. We will compare it with root. 42 is more than 40, so we will go towards right, but 42 is less than 56, we will go towards left. It is less than 50, then we will go towards left. 45, it is still lesser, so that's why we have inserted it here. But as soon as we have inserted it here, you can see that for this node 50, the height of left subtree is 2, there is no node in the right side, so 2 minus 0 is 2. And similarly for 56, the height of left subtree is 3, 3 minus 1 is 2. So both of these nodes are unbalanced because they are not satisfying the balance factor range. If you can recall, the balance factor range is -1 to +1. In fact, this is also unbalanced. But there is one node called critical node. When multiple nodes are affected, then we call one node as critical node, which is nearest to the newly inserted node. So newly inserted node is 42. So here we will consider 50 as critical node, and we will try to balance this tree with respect to this node. So I hope you are getting the meaning of critical node. Critical node means when multiple nodes are affected in a tree, then whomsoever node which is nearest to the newly inserted node, or the unbalanced node which is nearest to the newly inserted node, is known as critical node. Okay, and then we need to check what is the directional relationship between critical node and newly inserted node. So for example, if somebody is standing here and you need to guide that particular fellow to go to 42, how you will guide? You will say that okay, from 50 you take left, and then you will reach 45, and then again you have to take left. So this is left kind of relation. Okay, so this is unbalanced tree. First of all, that is clear, because balance factor is not satisfied. Critical node is clear, and then we need to determine the directional relationship, and that directional relationship in turn determines the kind of rotation which is used to balance this tree. So what is rotation? Rotation is basically as the name indicates, it's a kind of movement of nodes, so that unbalanced AVL can be converted into balanced. And these rotation are of four types: left left, in short we call it LL, then right right, right left, and left right. So these first two, LL and RR, these are known as single rotation, but RL and LR, they are known as double rotation. We need to rotate node twice. Okay, so while doing rotation, we need to determine which rotation is applicable. That is determined by the directional relationship between critical node and newly inserted node. As I just told, that here the directional relationship is LL, so we will apply this rotation LL. For instance, if nodes are so arranged that both the newly inserted nodes are on right, then we will call it RR. So we will discuss it with the example soon. Okay, so as of now this tree is unbalanced and we need to balance it. So in order to learn the balancing or rotation, let us consider a diagram. For instance, if you are being given three keys, 60, 40, 20, and you are being asked that okay, you need to insert these three keys in a AVL tree. So how you will proceed? Okay, so at first we have first key 60. Okay, so we will first calculate its balance factor, because it is the only key. So balance factor is 0 minus 0 0, because there is no child on left. Okay, so that's why height of left subtree is 0, as well as there is no child on right side, so height of right subtree is also 0, and 0 minus 0 is 0. This is the formula of balance factor. So this tree is balanced, we need not to balance it. After 60 we need to insert 40, as we know, as per BST property, 40 should go in the left of 60, because 40 is lesser than 60. Let us connect it. Okay, so as soon as we insert new node, then again we need to calculate the balance factor. For 40, again balance factor is calculated like this, that is 0 minus 0 is 0. But for 60, now there is one left child, and there is no right child. Okay, so how to calculate the balance factor of 60? In order to calculate the balance factor of 60, height of left subtree is 1, but height of right subtree is 0, and 1 minus 0 is 1. But still balance factor is lying in the range, because applicable range is -1 to +1. Okay, so both the nodes are balanced. Now let us insert the last node, that is 20. Okay, so again it will go towards left, and you can notice that this tree is growing only in one side. This is known as skew tree, and this particular example is left skew tree. So if somebody asks you in exam or viva what is skew tree, you can explain, which is growing only in one direction. And this is a kind of height unbalanced tree. Why? Because again, see, as soon as we do insertion, we need to repeatedly calculate the balance factor. For 20 it is left child is 0, right child is 0, minus 0 is 0, and for 40 it is 1 minus 0 is 1. Okay, but for 60, how to calculate this? Height of left subtree is 2, because the height of longest branch is 2, but there is no child on right side, so 2 minus 0 is 2. Okay, so as you can notice that for 60 the tree is unbalanced. For 60 the tree is unbalanced. Okay, so this is not allowed, because as per balance factor definition, the balance factor can lie only in between +1 and -1. Okay, so that's why we need to balance this. Now we need to determine which rotation we need to apply. So what is a critical node which is getting unbalanced? That is this one. The balance factor of this node is 2. Okay, and this is the newly inserted node 20, So what is the relationship, direction relationship? In order to reach from 60 to 20, we need to move from left to right. Okay, so that's why we need to apply LL rotation. So this is a kind of rotation which we need to apply. Okay, so I can write L and L. This is just for my own convenience. It's not necessary that you write. I am just telling you that okay, that why we are applying here LL rotation, because in order to reach from 6 to 20 we need to go first towards left in order to reach 40 and then here. So while solving such a problem, that while we are moving from left, so this is a kind of single rotation. In this case we apply rotation on the node on which first L is falling. Okay, so after this critical node, first L is falling on 40 and we will move it in opposite direction, which simply means that the parent node of 40 will become its right child. Okay, so I'm just showing it with the help of diagram. So after rotation, the new tree is like this. I am again repeating that while doing single rotation, that is LL, the first L is falling on 40 and we will move it in opposite direction, which means we will move it in right side. So now what is the meaning of moving it towards right? It simply means whomsoever is its parent. What is the parent of 40? That is 60. That will become its right child. So as seen in this diagram, 20 is unaffected. It is as it is left child of 40, but 60 has become its right child. So this is called LL rotation, and after applying this LL rotation, you can notice that the balance factor will automatically get balanced. For example, for 40 there is height of left subtree is 1, height of right subtree is 1, because one child here, and 1 minus 1 is 0. For 20 there is no left child, there is no right child. Okay, so height of left subtree minus height of right subtree is 0. For 60 similarly we have 0. So when you do a correct rotation, then the identification is that automatically balance factor of all node will become okay. That means they will fall in the range of -1 to +1. It's not necessary they all will become 0. For example, this is by chance become like this. Okay. Secondly, the BST property would be automatically applicable. Means, as we know, as per BST property, 60 should come in right of 40, 20 should come in left of 40. So that is also applicable. So this is how we are going to do the rotation. Okay, so I have taken single rotation example. In my next video I will explain double rotation as well as another single rotation RR. Okay, so that's it for today. Thanks for watching.